Now, we will try to understand the application of Reynolds transport theorem for a given problem. In this problem, we have a forces due to flow through expanding or reducing pipe bends. This is a pipe bend where the direction of the fluid is changing as well as the area of the pipe is also changing. Whenever there is a change in direction or change in magnitude, we know that there will be force. This force is applied. So, how can we calculate the force being applied on this bend? Means how much force is required to hold this bend stationary, right? In many engineering situations, we need to answer this question, that how much force is required to keep this bend stationary. So, for that we select this control volume between section 1, 2 and 3, 4, right, and then we develop the free body diagram of the fluid, and once we develop the free body diagram of this fluid which is enclosed between section 1, 2 and 3, 4, we can find out the force on this fluid, and once we can find out the force on this fluid, reaction of those forces will be the forces on the bend itself, right. So, we have developed this free body diagram. This is the water. Let us say if water is flowing through this bend, and then this is the liquid inside the bend 1, 2, 3, 4. This is the control volume. On this control volume, this face was in contact with the fluid. So, that fluid exert pressure P1, and with velocity V1, this fluid is entering in this pipe. At this section, this fluid was in contact with another fluid where pressure force is equal to P2. Now, this P2 and P1 we know always acts in such a manner so that it compresses the fluid. Now, at this end 3, 4, this fluid is entering with velocity V2, and this angle theta is also given to us as per the shape of the bend. Now, in this control volume, we have the weight of the fluid which is acting in a downward direction, and that weight of the fluid which is acting through Cg of this fluid element, and that weight can be calculated control volume of the control volume multiplied by weight density, and simply it may be written as mg. Now, we are assuming that this force Fx and Fy, these forces are applied by the bend on the fluid in the direction of x and y, and here we are assuming these forces as positive Fx and positive Fy. If it comes out to be minus, then it will be in minus direction, but this is our assumed direction of the forces being applied by the bend on the fluid. So, once we have developed this free body diagram of the fluid element inside the expander, now we can write the momentum equation in x direction, in y direction for calculating the force in x direction and y direction. So, by using the momentum principle, we can write two equations for this control volume, and by solving those two equations we can get two unknowns, which unknowns are Fx and Fy. Rest of the terms are known to us. So, let us go back and write the equation in x direction and y direction. So, please keep this figure in mind and try to write the momentum equation in x direction and y direction. So, how do we write equation in x direction? It means that we have to first find out summation of forces in x direction. So, what are the forces acting in x direction? This P1 is exerting force in x direction. What is that force? P1 multiplied by corresponding area at section 1, 2 will be the force acting in this direction, in positive x direction. Now, this P2 will exert force on side 3, 4 in the direction which is perpendicular to this surface, because pressure always acts in perpendicular direction, right. So, this is P2 multiplied by corresponding area. Now, as far as the x direction is concerned, then it will have one component. So, we have to resolve this force in x direction and y direction. So, with the help of trigonometry, we can resolve this P2 multiplied by A2 into cos of theta. This is the force in x direction. Now, weight is acting in y direction. So, it will have no effect in x direction because angle is 90 degree. Fy also will have no effect in y x direction, and x direction we have force Fx, right. So, this is the force in x direction due to the body force and surface force. Since flow is a steady flow, so we do not have to consider the acceleration effects or force due to acceleration, right.